So my dear children, this is a structure which made to demonstrate the arrangement of our planets in our solar system. Now first of all, at my far left corner you can observe the yellow color ball over here. That's the sun, the largest of all, right? So after that, at some kind of a distance, you can observe the Mercury, planet Mercury. So when you compare the size of planet Mercury with the other balls, if you can see it very clearly. If you compare the size, it has the smallest. So Mercury, the smallest planet in our solar system. Then after that, when you go somewhat right from Mercury, you can observe the second planet in our solar system, which is the Venus. Then after the Venus, you can observe the blue color one over here, the third one. So blue and greenish color planet, the planet that we are going to live, right? This is the planet that we are living in. So planet Earth. So planet Earth, the third one from the sun, right? This is the planet, the only planet which we can observe the life within the solar system. So it's the third planet from the sun. Then after that, in red color, somewhat similar to the size of Earth, right? You can observe the planet, red planet, which is referred as the Mars, right? So the Mars, the fourth one. After that, you can observe the longest ball among the planets, which is in orange color. This is the Jupiter, planet Jupiter. There's a special fact about the Jupiter, my dear children. It's that there's no kind of a crusty surface in planet Jupiter. It's like an air balloon, right? There's no crusty surface in it. Just a bunch of gases and dust particles, that's it. There is no crust in planet Jupiter, but however, it is the largest planet that can be observed within the solar system. After the Jupiter, you can observe the planet Saturn. That's the planet which has that awesome rings around it, right? The dust rings around it. So there is another fact about Saturn. It's the second largest planet of our solar system, right? Saturn. After the Saturn, when you go further, you can observe the icy Uranus and finally Neptune, right? So there was another planet in our solar system which called as the Pluto, but however, scientists have removed that thing from our solar system because it's been mentioned that in order to be a planet, there should be certain specifics. So Pluto is not following those kinds of specifics. So therefore, Pluto has been expelled from our family of solar system. Right now, up to now, we are going to identify, we are mentioning that only these 8 planets are there in our solar system. Earlier there was 9, including with Pluto, but however, in recently, scientists have removed Pluto from the solar system, the family of solar system in our solar system like this. So these are the planets once again in our solar system. You can observe the closest one, Mercury, then Venus, then Earth, Mars, Jupiter, Saturn, right? Jupiter, Saturn, then Uranus, then finally Neptune. These are the planets, the 8 planets that contained in our solar system. Right then, so let's head on to the classroom once again and we'll see what are the other things contained in our lesson. So my dear children, to observe the rotation of planets around the sun, or here to observe the rotation of a moon around a planet, same thing is going to occur in the same way, right? I have with me a ball fixed to a thread. Now I'm going to show you, after rotating this thing, I'm going to show you that the ball is not going to, it's not going to change the path, and it's going to rotate in the same way, in the same path, as long as I'm going to supply the force from my hand, right? So I have a ball with me fixed to a thread. Now I'm going to rotate and show it to you what's going to happen. So we'll rotate. Always remember, when you're rotating, we have to rotate it like this. So observe the path of the ball very carefully. As long as I'm supplying the force, it's getting rotated without any trouble. And always it is maintaining the same pathway around my hand. The pathway of the ball is not going to change from time to time. Always it is rotating at a circular path. You can see it very clearly, right? So reason for this thing is, when I am applying force by using my hand, right, upon that force the ball is rotating at a circular path because of application of that particular force. Now in the same way, if this is the sun, this is the planet revolves around the sun like this because of having this kind of a force. The force which binds the sun with the planet is referred as the gravitational force. So the two gravities creating one on each other is the force which resulting this rotation around the sun. And also the same thing is going to happen when a moon is going to rotate around a planet, right? So the same path or the same elliptical path is maintained as long as the gravitational force is there, right? So the two gravities are going to interact each other upon the rotations of planets and the moons, right? Then, so by looking at this activity, you can see that clearly the gravitational force is the one which is going to affect for the motion of the planets and motion of the moons. So my dear children, let's head on to the classroom once again and we'll see what are the other contents in our lesson. Right, my dear children, now we are about to discuss, or we are about to demonstrate how the phases of the moon are going to create. So you know that moon is going to revolve around the earth, right? Moon is going to revolve around the earth. In simple, we can say that moon is rotating around our earth, right? In simple, we can say that rotating, but however, the correct term is revolution. So upon the revolution of moon around our earth, different phases, right, different like shapes of the moon could be observed. So now I'm about to demonstrate how to observe those phases by using these simpler structures and instruments. So by using different instruments, so I have with me a styrofoam ball. This styrofoam ball is going to represent the moon. This is the one which is going to represent the moon, my dear children. And this bulb over here is going to show the light source, which is our sun, right? Now what I'm going to do here is, now I'm going to keep the moon like this in front of the sun. I'm looking at this surface of the moon. You know that moon is always facing towards us only through a one half, right? The other half is always darker. That's the dark side of the moon. This half, I can't see it. This portion, I can't see it. Always I am facing towards this portion. This is the portion which I could see. But right now, I can't see that portion. Why is that? Because light is not falling towards this surface. It's been completely covered. So I can't see this surface right now. Now I'm going to rotate gradually like this. Now gradually this area is going to visible like this. So when I'm rotating, now I can see a crescent like this. This kind of a crescent can be observed, right? When I'm rotating like this, then like half of the surface can be observed. So when I'm at this position, I can clearly observe the entire surface, because the light which is falling from the sun now completely covers the moon, so that I can see it very clearly. At this position I can observe the full moon. At this position I can observe the full moon. Entire surface of the moon is now visible for me. So when I am going to rotate once again like this, gradually this thing is going to disappear, right? And once again, when I am coming to this position like this, now once again I can't see the surface, right? So this position is referred as, at this position, as I can't see any crater or any crescent of the moon, this position is the new moon, right? So this is how the phases are going to create. You can do this thing at your home, right? Observe the this half while rotating gradually like this. That's how to observe the crescents created during the revolution of the moon. Now, my dear children, I'm going to show how we can observe, right? How you could observe by using these setups. I'm going to show that how you could observe the crescents or the phases of the moon. But however, remember these things. Always the moon is going to revolve around the earth, right? So you just observe. When I'm going to keep and rotate this thing, you just observe how the phases are going to create within the moon. That's it. Don't confuse this thing with the eclipses thing. Okay? Just for a demonstration only, I'm going to show how the craters are going, how these crescents are going to create, how the phases are going to create. That's it. Okay? Don't go and think about further things related with the eclipses, right? In order to give you a more pleasant idea, more good idea, I'm going to show by rotating this structure around the light bulb. Okay, right. So now let's observe how to observe, or how you could observe this thing by using these instruments within the video itself. Okay, so my dear children, now I'm going to show how the phases would create within this particular thing. But however, this is just to show you how these phases are going to work, right? Don't mess up this thing with the eclipses thing. Actually, now there is earth like this, and around the earth this is going to rotate. Okay, remember that thing. Okay, around the earth this thing is going to rotate. Here you can observe the first quarter. We'll imagine that this is the first phase. So in here the whole moon has got darkened right now. Remember, here this is for the educational purposes only, to observe only with the phases. So this phase is the, right here you can observe. Don't think about the light source in here, right? Just think about the surface which you can observe over here. Okay, so the surface is now entirely dark, right? The surface is entirely dark. That means this is the new moon. Now I am going to rotate it gradually. Observe how you can get the crescents, right? See, now you can clearly visible how the crescents are going to create. So when I am going to turn and come back to this position, this is called as the full moon. Now within full moon you can see that the whole surface is very clear to you, right? Then once again, when I'm going to rotate, you can see that the surface is gradually getting darker, and once again completely getting darker. This is the new moon again, right? So you can observe the crescents over here. Then the full moon over here. Once again another crescent over here. And again the new moon in here. Right? So this is how the phases are going to work, my dear children. So my dear children, now when I am rotating this thing like this, you could observe the creation of, when I am rotating like this, you can observe the creation of crescents very well. However, there is a small bit of a problem over here. Now, this is also identical in creation of a solar eclipse. So don't miss that thing with the solar eclipse thing. Okay. Within this position, you just observe this surface and how it is being darked. Right. So for the camera, there is no possible way to show this thing. That's why I demonstrated like in the previous way. Right. So don't mess up with the solar eclipse thing. Just observe how the crescents are getting created. That's enough, right? I'm showing only the crescents like this. Okay, just observe the crescents like this. So this is the full moon, right? So Earth is there. Remember that Earth is there at this position, right? So this side is the, right, Earth is there. Now this is my like my fingers are the ones which are showing you guys, and this side will imagine this side, the finger side are the ones which are showing you guys. So as you guys are here, as the moon is in here, you can clearly observe the entire surface, right? Imagine that you are at the end and it's rotating like this, right? Like this. So the ball is not rotating, passing you guys, and you are at the middle like this, not at the end. Okay. So don't think that much of a detail in here. Just observe the crescents. That's it. Okay. Don't mess up with the solar eclipses thing, right? Okay then. So my dear children, I think that you got the idea how the crescents are getting created, or how the phases of the moon are getting created when the moon is going to revolve around our Earth. So let's head on to the classroom once again and we'll observe what are the other things contained in our lesson. So my dear children, as you can see here, this is the instrument that we use to demonstrate eclipses. So mainly within this part we'll be explaining how does a solar eclipse is going to occur. So this yellow color object, this one is the largest one, as you can see here. This blue color one is our planet Earth, right? So this larger yellow color one is our sun. So over here, as you can see, there is another small bit of an object. This one, this is the one which is referred as, or this is identical to our moon, right? So by looking at this instrument, you can see that the size comparison of the sun, Earth and our moon as well, right? Okay, so when I'm going to move this arm of the instrument, you can see very clearly the Earth is going to revolve around our sun like this, right? And as well as you can see that the moon, right, the replica of the moon also going to revolute around our earth like this. Once again, see, observe very clearly. When I am going to rotate this arm, the earth is going to revolute around the sun, and also the moon is also revoluting around our earth. So at a certain instance, what will happen, my dear children? The moon will come in between the line of our sun and the planet earth. So in that case, the shadow of the moon is going to fall on the earth. So that's how the solar eclipse is going to occur, right? So now within this environment, there is plenty of light, so we won't be able to observe it very clearly. So in order to observe this thing, my dear children, what you have to do? You have to put off all the lights and the room should be darker, right? So we'll dark our room and let's demonstrate how to observe the solar eclipse and how to study the solar eclipse. So my dear children, now as you can see here, now this is our sun, this is the moon, and this is the planet earth. Now all of these three objects are now on a straight line. As you can see here, this one, sun and the moon and the planet earth is now on a straight line. So as you can see here very clearly, the sun is now lighted up, right? So we are going to use a bulb in order to light up the sun, right? So in this space, the shadow of the moon is going to fall on these kinds of countries. On these countries now, they will experience a total solar eclipse, right? This is the shadow of the moon. Now for this area, right, for this area, sun is now completely being covered. How does it is getting covered? By the shadow of the moon which is falling on here. But for the countries over here, they will experience the sun, or they will experience the solar rays without any trouble. Only this part is going to experience the solar eclipse. As you can see here very clearly, this is the shadow of the moon which is falling on this particular area. So now you know that planet Earth and the moon is not going to stay on the same position. It's going to revolve. So when revolving like this, once again this straight line thing is going to disappear, and see, right, now the straight line thing is going to disappear. And my dear children, once again, for the people around this area, once again they will experience the solar energy or sunlight. So this is how to demonstrate the solar eclipse by using the instrument over here. So my dear children, once again, as you can see here, when these three are on a straight line like this, the shadow of the moon is going to fall on this particular space or on this particular area, and that particular area is going to be covered by the shadow of the moon. So when I'm going to move it like this, right, as you can see here, you know that moon is going to revolve around our earth, so the position of the moon is not constant. Okay, so when I'm going to rotate this thing like this, the position of the moon once again changes, and the people around this area, once again they will experience the sunlight. Okay, so my dear children, this is how to explain or to demonstrate the solar eclipse. So once again we'll head on to our classroom and we'll study the further things related to the eclipses. So my dear children, now by using the same instrument over here, we are going to demonstrate how does the lunar eclipse is going to occur. So this is how the lunar eclipse is going to occur, my dear children. Now in a lunar eclipse, what happens? this is our planet Earth. Like I said in the previous case also, when we are studying about the solar eclipses, it's pretty much easy to observe the planet Earth, which is in blue color over here. This is our sun and this is the moon. So my dear children, as you can see here now, moon, earth and sun is now on a straight line. So when sun is going to produce light energy, okay, the people around this area will not be able to see the moon over here, because as you can see here, now the earth is in between the moon and the sun. So the shadow of the earth is going to eclipse the moon. So here, my dear children, for the people around this area, they can see the bright full nature of the moon. So we know that lunar eclipses are going to mainly occur within a full moon day. So like this, my dear children, we can demonstrate the occurrence of a lunar eclipse. So like in the previous case, we have to darken the room in order to observe the lunar eclipse quite well. So we'll darken our room and we'll see how to demonstrate the lunar eclipse. So my dear children, now we have darkened the room or our environment. As you can see here right now very clearly, this particular area of the moon, right, is now in darker color. It's mainly because the shadow of the earth is now falling onto that particular area, right? So the people who are in this place of the earth will experience the lunar eclipse. Okay, so when the moon when the moon is going to come to this particular place, people around this area will definitely experience the lunar eclipse. Okay, so my dear children, the other specialty in here is that when now you know that moon is also going to revolute now. So when the moon is revolute around the earth, when the position of the earth is also going to change around the orbital axis of the sun, right, once again the moon will be available to observe for the people around here. So it's very clear to us that during a lunar eclipse, the shadow of the earth is going to fall on the surface of the moon. So that's how the lunar eclipse is going to occur. Always remember, this incident can only be observed during a full moon day, and sun, earth and the moon should come into a straight line like this. So in that particular case, shadow of the earth is going to fall around this area, and this particular area or this half of the moon is going to cover by the shadow of the earth. That would result a lunar eclipse, right? So it's pretty much obvious and clear to us. Lunar eclipses are going to occur upon falling the shadow of the earth on the moon. So my dear children, now we have studied about the lunar eclipse. How does the lunar eclipse is going to occur? So you know that, like I said in the earlier case, when the earth is going to change the position, once again like this, now the people in these places can observe the moon. It's because now in this case, these three objects are not on a straight line. Okay, in order to observe a particular lunar eclipse, it should be on a straight line like this, right? Now the shadow of the earth is going to fall on the moon. So my dear children, this is how to demonstrate the lunar eclipse then. So we'll head on to the classroom once again and we'll study further things related to the lesson. So my dear children, you know and you have experience about this instrument. When we are studying about the solar eclipse and the lunar eclipse, I have shown you this instrument. So by using this particular instrument, my dear children, we can demonstrate several incidents related to the phenomena in our solar system. So mainly we can use this instrument in order to observe lunar eclipses and solar eclipses, right? So when we arrange, so you know that I can rotate this arm like this. So when I'm rotating this arm, as you can see here, the earth is going to revolute around the sun, and also moon is also going to revolute around our earth. So when it is coming to this kind of a position right now, sun, earth and our moon is on a straight line. So the shadow of the earth is going to fall on the moon. At this particular position, my dear children, a lunar eclipse is going to occur, because for the people who are living around this area will not be able to observe the moon, because the shadow of the earth is going to cover the surface of the moon. Now within this particular position of the sun, earth and moon, we can observe the lunar eclipse, my dear children. So as I'm going to rotate it once again like this, like this. Now my dear children, as you can see here, now between sun and earth, moon is there. So for the people who are living in this particular place of the planet earth, will not be able to observe the solar energy or sunlight. Sun is going to be covered by the shadow of the moon over here. So in order to happen this phenomena, sun, moon and planet earth should be along a straight line like this. Now in this particular moment, my dear children, for the people who are living in this area will observe a solar eclipse. So by using this instrument, we can demonstrate lunar eclipse and as well as the solar eclipse. Okay. So it is pretty much clear to us that during the solar eclipse, like in this position, shadow of the moon falls on the earth, and like this, during the lunar eclipse, my dear children, now this is the lunar eclipse position of sun, earth and moon. During the lunar eclipse, my dear children, shadow of the planet earth is going to fall on the moon. So it's pretty much obvious to us that these shadows are the main reason for the occurrence of eclipses. Not only the eclipses, my dear children, here also we can demonstrate the revolution of the planet earth around our sun. So as you can see here, when I am moving this arm, planet earth is going to revolute around the sun. See? So we can demonstrate the revolution of the planet earth around our sun also. And also, when I am revoluting the planet earth, you can see that the revolution of the moon around our planet earth. So all of these things can be observed. While it is going to revolute around the sun, once again you can see that our planet earth is also going to rotate around its axis. So the rotation of the earth can also be observed from this instrument. Rotation of the earth also can be observed, right, like this. So this instrument can be used in different demonstrations like this, my dear children. So let's head on to the classroom once again and we'll write down what are the things that we can demonstrate by using this instrument. So my dear children, this is the instrument which referred as the clinometer. Actually, this is a sample of a clinometer which prepared by using the protractor, right? Sample of a clinometer. So what you have to do is you have to see it from here and you have to look at the star like this. So by the angle over here, which is getting created with the 90-degree angle like this, when you are observing, you can get the location, right? You can get the location, the clinometer. So as you can see here very clearly, when you are turning here and there, right? Actually, you have to keep it like this at a 90-degree angle like this. Then it should be parallel to the ground. Yes. Now you are going to observe the particular star or whatever the celestial object like this. So by that way you can get the angle, right? By that way you can get the angle which the celestial object is located in our sky. Okay. And by that way you can get the location as well and the distance. You can even calculate the distance also. So to get the location, we use the instrument which is referred as the clinometer, right? This is referred as the clinometer then, right? So my dear children, let's head on to the classroom once again and we'll observe what are the other things contained within our lesson.